So the last tutorial of week 5 is the 5.3. Just deals with a couple of useful little objects that you should know about. This won't take very long. The first of those is the key object up here. And the key object is basically just an object that captures your keyboard as you're typing. It outputs three values. It outputs the ASCII value of your keystroke, the key code on your keyboard, and any modifiers. Those would be shift keys, alternate keys, option keys, command keys, and so on that happen to be down. And you can do whatever you want with this data. But you can see that as I start typing, just randomly, you can see all of the data. If I hold down the shift key and do that, I've got a modifier of 512, and the command key will be something else. Well, the command key made my screen made my window disappear, so I'll bring that back. There we go. Anyway, maybe don't do the command key or the control key while you're doing that. All right, so this is the key. Now, I should explain what ASCII is, what key codes are. ASCII is the character value. ASCII is basically a format where all characters are associated in numerical value. And this is a standard that basically computers have used for decades for representing characters. Now, of course, we have something more complicated called Unicode, which is much more extensive and includes characters from other languages. But when ASCII was first developed, there was only 256 characters that anyone could imagine anyone ever using. Because the assumption was that you would only be concerned with English and perhaps some European languages with accents and so on, but no Korean or Chinese characters or anything that was so foreign. So ASCII is somewhat limited, but it works well for the keyboard. So for example, if I type I type on my keyboard 0, I get 48. And 1 is 49, 50, 52, 51, 52 as I go up. Number 5 is 53, and so on. The letter A is ASCII code 97. The capital A, uppercase A, is 65. Uppercase B is 66. So there's some kind of alphabetical logic to the way ASCII characters work. There are also some characters that, like the space bar, is 32. The carriage return is 13. Sometimes it's 10, but on this computer it's 13. And so every character that you would be typing, let's say in a text editor, will have some ASCII value to it. Now the key code's a little different. The key code is actually a numerical value associated with the physical keys on your keyboard. And this will be different from keyboard to keyboard. So for example, if I type this, that's a 1 on my number pad on my keyboard. And that's key code 83. But if I type the number 1 up here, it's key code 18. Right? So this is, in a sense, a mapping of your particular keyboard, which can be independent of the ASCII codes. And modifiers I've already mentioned. So a simple thing that you might do when you've written a program is simply say, have a select underneath the key, look at the ASCII character and say, okay, is it a carriage return? 32 a space bar, 48 is a 0, or an A. So if I'm typing and I type A, you can see that flash. If I type return, you can see that flash. And every time I hit the space bar, you can see that flash. And the last one was the 0, which is there. So I can use my keyboard as a controller if I want, fairly easily. So I just wanted to mention that. We haven't really looked at doing that, but it actually sometimes can be the simplest way to trigger an event. You can simply say, click on the 1, and then the first section of your piece starts, and then click on the 2, and the second section of a piece starts. Okay, the delay object. right in here. The delay object takes one argument, and that is the delay time in milliseconds between a bang coming in and a bang going out. So this one is set a delay 2000. If I click on this, and 2 seconds later the bang comes out. And I'll make it nice and big so you can see it. Bang. Okay. And obviously I can change that value, so I can have this at 500. Anytime I bang, 500 milliseconds later, the bang will come out again. And these values can be in any of the values that are supported by Mac. So if you have the transport running, it could be a note value. You could delay for an 8th note or a 16th note. Now there's one quirk with delay that's very important to know about. And that is that delay, when it receives another bang, it restarts its delay. So if you bang it a second time before its time has expired, it will not put out that first bang, but reinitialize the delay. So you can think of it as there's only one delay line in here. And if I start it, it's going to wait 2000 or 500 milliseconds, and it's going to put the value, it's going to put a bang out. But if I click it again, it restarts it. So for example, I'll put 1000 in here to give me some time. And I'm going to click this. Click it, click it, click it, click it, click it, click it, click it. As long as I keep clicking it, it won't put the output, it won't bang the, there won't be a bang coming out of it until I stop, and there it happens. Okay? So that's not really a bug or anything. It's just the way the delay was designed. Now, pipe, on the other hand, is a slightly more complicated object, because unlike delay, it does not reset itself, and it will allow you to put other kinds of data in, and it will delay and push that data out again. So for example, if I go into delay here and I slide my mouse up and down, we'll see all of that data coming out. And I can keep doing it, and it's basically following me 2 seconds behind. Okay, so that could be a very useful object. It's what we call a delay line. It's kind of like it works the same way as a digital delay works. Whatever comes in gets buffered for a certain amount of time and then gets put out. And the data just gets pushed through and waiting, and then it comes out after that period of time. So you could imagine us using this in some sort of musical way, where I've got now a pipe that's got 2 arguments, it's got 3 arguments. This one only had 1. With 3 arguments, it basically is going to store 2 values. A value coming in here and a value coming in there, and then whatever delay time is set, which I could alter in here. So this has got a 5,000 millisecond delay. So if I play some notes, I get that delay coming out 5,000 milliseconds later. So I can immediately start imagining things that we could do with this. Let's straighten this out, and let's just think about what we could do. Let's make our delay time shorter. Let's make it 500 milliseconds. I'm just going to put some triggers in here. I'm going to duplicate that, put some triggers in here. Okay, so let's send this one into here where it gets delayed. Actually, let's send one straight in here. It doesn't matter which one we send, actually. All right, so I'm just going to switch these around because I don't like these crossing. There, that's better. So one of these is going directly in to my make note, and then the second one is going into a pipe. But let's actually do something like, let's add something to it. Let's add 4 to it. And let's duplicate that. I gotta I didn't put this in the right place, did I? Okay, I've got to have my pitches and my velocities coming out. Velocity goes in there, pitch comes in there, pitch comes in here, velocity goes in there. Let's add 7 to this one and send it out here. So what happens now if I just do this? So I could now start imagining, well, what would be, I could make these much shorter, maybe 100 and 200, and maybe I could do one more of these since I've got all of them set up, and make it 12. Got that one, got this one, that one, this one, and this one. And this would be 300. So you could imagine it, doing something much fancier than that, being able to arbitrarily set up a whole sequence of delay lines. You could build an arpeggiator out of this with a little bit of abstractions and a little bit of a cleaner patch than I have right here. But you see the principle of setting up using the pipe. And whatever comes in, that includes the node-ons and the node-offs and the velocity values, all of those are subject to the same delay, the delay time that's specified in the pipe. So that's pipe, delay, and key.